Good evening, everybody, and welcome to ML Ticket. And we are now in the middle of an ongoing project. We have picked up a data set on the California. Specifically it's a California housing data set from 1990, and we're trying to predict the median house value. That is basically the house value of the particular house. We will be giving other things as input parameter as the inputs, and we want that house value to be predicted. Okay, so till now we have completed the many things. So let me just present my screen and let's get started. And for your information, today I won't be coding anything because today we have a theoretical part of the machine learning. So till date I have not taken any particular theoretical aspect of machine learning. I have always shown you a practical aspect. But to be honest, today I have to take up a theoretical some of the theories. I need to clear up some of the theories because if I don't clear up these things later when we start to code and I'll use these terminologies, I'll use these things, you won't be able to understand or comprehend along with me. So that's why it's a good idea to just get you familiarized with some of the terms that we will be using. Okay, so let me just wrap up everything that we have done a little fast so that we can understand. So we started with data visualization, and I told you that a machine learning project can be roughly divided into three main categories that are data visualization, data pre-processing, and ML algorithms. As I said in the last session, we completed pipelines and we generated our data that needs to go inside our model. And our model will be trained over the data. We have prepared that final data. So we have completed data visualization, we have completed data pre-processing. Now we are entering into ML algorithms. So till now we have covered a lot of things. We have covered why data visualization is important, then conclusion from the histogram that we generated using the visualization, why data pre-processing is important, um, what is the problem with the random sampling and all the sampling techniques, missing values, what is the solution to the missing values. We also talked about the three possible solutions that I am familiarized with, and also I told you. And we dedicated an entire session on this, so I don't think I need to repeat everything. We also dealt with the categorical values. We discussed the types of categorical values that we have. We did feature scaling, uh, and then pipeline. Last session was everything about pipeline. So now we start with the styles of machine learning. Okay, I have talked about the styles of machine learning before when we first started this project. But just for the matter of fact, I am going to share that information once again so that you people can recall everything, because we have done this at least I think 8 sessions back, if I'm not wrong. So let's get started. What are the types of the machine learning? Okay, I have only covered two types. There are few more types, but as a beginner you don't need to get into such details. Okay, as a beginner I would always say you should limit the information that you're getting, because this is a very very vast area that we are entering into. And many people are researching about this thing every day, and everything new research paper have are being published. And to be honest, that's why I would say it's better to limit yourself to a particular sense of knowledge. Of course, after you get a healthy knowledge about everything, how the process works, then you can start expanding your knowledge. So but first I would like you to limit your knowledge to a particular sector, else it will become boring or it will become overwhelming, because these things are a little bit theory. We need a little theoretical aspect to these things. so that we can understand it very clearly. So let's start it. So what is the first? What are the styles of machine learning? The first style is supervised learning. If you remember this problem, this particular machine learning problem statement that we have chosen is also a supervised learning problem. Okay, so the thing that we are dealing with right now is a supervised learning problem. So what is this? And I am going to explain this once again because this is important. So input data is called training data and has known label or results such as spam or not spam or a stock price at a time. A model is prepared through a training process in which it is required to make predictions and is corrected when those predictions are wrong. The training process continues until the model achieves a desired level of accuracy on the data. As we have talked about the supervised learning, we use labeled data. The data which is given to us is has been labeled. Okay, we understand the every numbers that we see, and in the data set we know that which is the latitude column, which is the longitude column. We don't have to assume stuff, right? We know that this is the latitude, this is the longitude, this is the housing median value, this is the household, this is the population. We know that the data is labeled. So that's why this type, when the we are working with labeled data set and we are addressing this kind of problems, this is a supervised learning problem. Okay, so what do we have here? And example problems are classification and regression. Classification and regression are one of the most famous supervised problems. We are currently dealing with a regression. To be precise, we are dealing with a multivariate regression. If you don't remember what is a multivariate regression, I would like you to Google that stuff. I have already talked about it. And what is a classification problem? Um, in one word, we in regression problem we are actually predicting a continuous value, right? But in classification problem we classify a particular category, that's all. So we have not done classification problem, we are only going for regression problem. But if you want later after this project, I can also do a classification based project which will give a greater aspect. We will dive into a greater aspect into this particular classification problem. Okay, so what are some of the example algorithms are logistic regression, back propagation and neural networks, and also linear regression, and many more. Okay, so back propagation neural networks, this is a algorithm used in deep neural net, I would say, and we are not going to use this. Logistic regression is one thing we you will be familiarized. I will talk about it, but not in a great deal. So let's get moving, and we will explain. I will explain as we go. Okay. So what is the next type? We are also. I have also talked about this particular type of learning, that is unsupervised learning. So the input data is not labeled and does not have any known result. This is called a unsupervised learning. Basically, the exact opposite of this supervised learning. Okay, a model is prepared by deducing structures present in the input data. It may be extract general rules, it may be through mathematical process or systematic reduced redundancy, or it may be to organize data by similarity. Example problems are clustering, dimensional reduction, and association rule learning. So these are some of the examples that we can address using unsupervised learning. Now you may ask, what are these problems? I have never heard of this dimensional reduction clustering, because these are, I would say, intermediate level problems. These are not beginner level problems. I am just giving you an example. Okay, I'm not going to explain. We are not going for a unsupervised learning right now. Some of the algorithms are a priori's algorithm and k-means algorithms that uses unsupervised learning. Okay, again I am saying that this particular problem is a sorry, it's a supervised learning problem. This is not an unsupervised learning problem, but since I am talking about it, I just give you the information. There are another form of learning that I have not talked about is reinforcement learning. To be honest, I don't want to talk about it right now because it's kind of little hard to understand. Man, it's a mix of supervised and unsupervised learning. That is, it is a mix of labeled and unlabeled data. And to be honest, at this point, it is a little difficult for me to make you understand because you don't have the basic, you don't have the clarity on the basics of machine learning algorithms. So I would like you to just limit yourself to the knowledge of unsupervised learning. We are not even trying going for unsupervised learning, but still you should know what it is. Reinforcement learning, you can just keep this thing in mind. It is a um, it's a mixture of labeled and non-labeled data. Okay, so that's all. Mane, we don't have to get into a greater depth, but if you want me to talk a little bit more about what is reinforcement learning, please let me know. Then I'll be taking extra session on this particular regression problem. Okay, sorry, reinforcement learning. So the list of common machine learning algorithms. This is a particular list of common machine learning algorithms that you will be dealing with as you go from a beginner to expert. I would say linear regression, logistic regression, decision tree, SVM. That is support vector machine, knife based, KNN, K means, random forest, dimensionality reduction algorithms, gradient boosting algorithms. Okay, these are the algorithms listed from beginner to expert. Okay, the first few are beginner, and the middle are intermediate, and then we go to the advanced stuff. Okay, so linear regression, I won't be talking about every algorithm in this puzzle. It is not possible. You have to understand this thing, that it is not possible for us to understand everything under the hood. Okay, and it will take another 20 sessions for me to pick up every other algorithm and explain them individually to you, but it is not possible for me to do that. But I am going to just give you the taste of the algorithms that we are going to use in this particular project. We are going to use only three algorithms, that is linear regression, linear regression, uh, decision tree, and random forest. As from the previous one, there is the first linear regression, a decision tree, and random forest. Mostly, I may or may not use logistic regression. I am not sure. I have to look into it once more, but that's all. So I will be only talking about linear regression and decision tree. And to be honest, random forest is easy if you understand. Once you understand decision tree, random forest is nothing, just. So I'll be talking in a elaborated fashion about particularly about these two algorithms, so that you have a greater clarity about these two algorithms. At least these are the most basic algorithms that you should be Sorry for the inconvenience. We had a slight error while recording. That's why I had to stop. Okay, so let's continue. So, what is this? We have you have seen this particular equation. I'm very sure that you are familiarized with this equation. That is y equals to mx plus c. This is another variant that is ax plus b. That's same thing. Okay, so I don't think I need to explain much about this particular equation because you are very familiar. I am pretty sure that you have seen this equation. So let me just get to the thing so that you can understand the way that I want you to understand. Okay, so the best way to understand linear regression is to relive this experience of your childhood. Let us say you ask a child in fifth grade to arrange people in his class by increasing order of weight without asking them their normal weight. What do you think a child will do? He or she would likely look visually analyze at the height and build a people and arrange them using a combination of these visible parameters. This is linear regression in real life. The child has actually figured out the height and the build. The height and the build would be correlated to the weight by a relationship which looks like the equation above. Okay, so if you just imagine by this particular situation in your head, you are not told about the weight, but you are asked to arrange the people according to weight. But you can just visually analyze these people and can arrange them, and most of the time you will be correct enough, right? You will be very close to the perfect order. Okay, so this is the particular linear regression in real life. This is nothing very fancy, to be honest. This is the most easiest machine learning algorithm to put in. Okay, and to be honest, mathematically it's also very sound to understand. Okay, so let's get okay. So if you draw your attention to this particular graph, you can see the there is a black line. Okay, this black line is particularly is the black line is the best fit line, and all the other dots are like the values. Okay, so this coefficient a and b are derived on the basis on minimizing the sum of the squared difference of the distance between the data extra of the regression. Now you may understand, you may not understand this particular line, that minimizing the sum. What is this minimizing the sum of squared differences? I'll be talking about it a little bit later, but just hang with me. Look at the example below. Actually, it is now above. Here we identify the best fit line having the linear equation of this. Now using this equation we can find the weight knowing the height of a person. So this is how you actually linear regression works in the model. Now you need to understand this thing. We don't need to do this. We are not need to write these equations and all. Nothing has to be done. Okay, we are only going to take the instance of that particular class, I mean linear regression, and apply that model. Okay, that's all we are going to do. But it's a very good practice for you to understand what is going on behind the stage. Okay, I won't say you have to understand everything that is going on. I am not asking in this case the math is very easy to understand. Okay, so that's why you can easily relate, but in some case some of the algorithms there are the math is way more tough. It can includes calculus, high level statistic, advanced level probability, some cases and all. So sometimes you may not understand the math, but you need to understand the story behind it. As I mentioned previously, you have to relate to a particular story. Yeah, like this child that arranging people according to weight without knowing their weights. Okay, you have to create a story inside your head, I mean, after you understand this stuff, so that you can remember remember it for the rest of your life. Okay, you don't need to buy heart anything here. You don't need to buy hard your formulas or anything. Every hard work will be done for you. Okay, you just need to understand. I'm always stressing on the point, Jay. Only thing that you need to do is to understand. The code is very is ever changing. The code is ever changing. Okay, very versatile. People write versatile code and everything. Okay, so we are done, mostly done with linear regression. So let's move on. The next thing that we have is decision tree. This is one of my favorite algorithms and I use it quite frequently. It is the type of supervised learning algorithm that is mostly used by classification problems. Surprisingly, it works both categorically and continuous dependent variables. In this algorithm, we split the population into two or more homogeneous sets. This is done based on more significant attributes, independent and variables to make a distinct group as possible. Okay, so basically, decision tree is a very good algorithm for classification problem, but it is so surprisingly sometimes it works very good above on মানে, this continuous or dependent variable like regression problems basically. So what it does, it divides the data. You can understand it better here. You can say the dependent variable is play and don't play. We divide it into each categories like, okay, what happens if it is sunny, overcast or rain, or what is the humidity level, and what is it is windy, or is it true or false. In this image you can see that the population is classified into four different groups based on the multiple attributes to identify if they will play or not. To split the population into different heterogeneous groups, it uses various techniques like Gini, information gain, chi-squared, entropy. These are one of those, what do you say, statistical factors that are involved. To be honest, decision tree is not very complicated to understand. Okay, I would like you to go through this decision tree and come up with a story just like the linear regression so that you can understand it better. I am going to leave this thing as an homework for you guys so that you can at least have some fun because uh, you don't need to understand the math behind it. You just need to come up with a story that explains this particular decision tree, such in the case of linear regression. Okay, so what is the next thing that we have to talk about? We have to talk about this particular concept of overfitting of data. Okay, don't you worry. I will be going through everything again. So don't you worry. So overfitting of data. Imagine that you have, of course, you have to imagine stuff. Imagine okay, I have written the wrong thing here. That you someone cheated on you. Imagine that someone has cheated on you. Now you as a human will be furious and will be tempted to say that all girls or boys are like this only. Of course, we do this thing every day almost in our life. Somebody did this thing to you and you are generalizing stuff. Overgeneralization over a particular fact is not good in any way, right? Since the person is cheating on you, but you cannot generalize that to every boy and girl or whatever it is in your case. Okay, so that is not a good way to judge people or to understand or to learn things, right? Similarly, our model. Oh, I have made so many typos here. Very pardon me for this. Similarly, our model can also fall into the same trap if we are not careful enough. So similarly, our model is like a human being. I said this is like a child, right? So if we allow our model to overgeneralize stuff, so it won't be giving us good outputs. In machine learning, this is called overfitting. The same situation, this particular overgeneralization of a particular fact, is also known as overfitting in case of machine learning. It means that the model performs well on training data but does not generalize it well. Basically, it performs very good on the training data but does not perform good when it comes across some of the test data and something like that, or real life data. So we don't want our model to overfit. Now you may ask, okay, I understand this what you are saying, but show me an example, right? I don't understand. I cannot imagine things without an example. But at this point, I won't be able to show you an example, because if I start showing you the example, I have to write the code, and I am reserving that part for tomorrow, because we have actually a lot to cover today. So we have a theory class today only. We are not writing any kind of code. So let's get moving on. Let's move on, and let's see what comes next. Underfitting data. As you might have guessed, underfitting is the opposite of overfitting. I don't need to explain underfitting, because it's just the exact opposite of overfitting. It occurs when the model is too simple to learn the underlying structures of the data. You can imagine this as sarcasm. Basically, when someone is saying something in sarcastic manner, and the person you are suppose you are saying commenting on somebody in a sarcastic manner, and that person is not understanding their underlying sarcasm, and he's just nodding on to your she's just feeling, he or she is just feeling that you are saying a simple thing, right? So she or he is not understanding the underlying bully or underlying pinch that you are actually trying to convey. So this is kind of like sarcasm. You don't understand. Some dumb people don't understand. People who don't understand sarcasm cannot get the underlying fact under that particular sentence. In the same way, sometimes our model is so simple, it become we are going to design the model so simply that it does not understand the underlying structures of the data set. And at that particular point, yeah, the data begins. This type of model is known as underfitting data. The data, the model is underfit. We say the model is underfit. How the model is underfit, we will be looking at the code, I think, in the future sessions. So don't you worry, we will be coming back to it again and again. This is a very important aspect, so don't you worry. Reality is just more complex than the model, so its prediction are bound to be inaccurate. Okay, so we have talked about many things. We have talked about machine learning, styles of machine learning, supervised, unsupervised. Then we came across some two algorithms like linear regression and decision tree. But haven't I said that I would also talk about random forest algorithm? Yeah, just imagine, it is very easy for you to understand random forest once you have got the heck of decision tree. Uh, if you take a decision tree on every possible outputs, if you take the decision tree on every possible outputs and take the best accuracy score, this taking every possible decision tree is known as random forest. Basically, a random forest is a collection of decision trees. Too many decision trees make up a random forest. So random forest is nothing very great to nothing too complicated to understand. It is made up of many decision trees. That's all. And it also works very good for the regression problem and all. So this is the thing. Okay, so basically I have only talked about two or three algorithms on machine learning, but as I have shown you that there are many algorithms here, like so many. These are only the some of the most famous algorithms that I have listed. There are so many algorithms that you can't even imagine. I think as we are talking, an algorithm is now discovered at also. So you don't have to learn everything. Okay, as I said, as a beginner, if you start learning everything, it will be very overwhelming, and you will think this thing is not worth it, and you will start quitting the machine learning genre. That's why I would say limit yourself to a particular set of informations and learn everything about that particular set of information. Once you get the heck of it, the other things becomes very easy for you to learn. It's kind of like um, it's kind of like having to know how to add subtract, multiply, and divide before you start BODMAS, right? When you are learning BODMAS, if you start learning about plus, minus, and multiplication, everything from the scratch, it will be very overwhelming for you to understand. But if you have already known plus, minus, and plus, minus, multiplication, division, it will be easy for you to keep things together and take things together, and you will understand it better in very less time also. So I ask you to just limit yourself to certain information. Now you may ask, what is the limit that I should be uh, maintaining? Okay, I would just say I am covering some of the algorithms here in this project, and I would say learn anything and everything about those algorithms. I cannot discuss everything here. Okay, if I start discussing everything here, this ML session will become a math session. Okay, so this is not the case. I'll be showing you examples. Don't worry. I'll be showing you practical examples of how to do this stuff. But if you want to know everything about these algorithms, I would ask you to go and Google, and you will understand. This is not very tough. Okay, once you understand one or two algorithms, you will get the heck of everything. Once you start making up a story for relating a story to every algorithm, you will remember that till your last breath. Okay, it is nothing very special. So I've shown you linear regression and decision tree. These and random forest. I also told you about random forest. So these are the algorithms that mostly we are going to use. And last but not the least, I am going to talk about something which is known as RMSE. If you're not familiar with this term, let me tell you. RMSE stands for root mean squared error. Okay, this is a very famous checking measure, accuracy checking way. Okay, root mean squared error is highly, most of the case we use RMSE to see whether our model is good or not. So what is this thing? Let me just uh, define this. Root mean squared error is a standard deviation of the residuals. Residuals are the measure of how far from the regression line data points are. Okay, RMSE is a measure of how spread out these residual data are. In other words, it tells you how concentrated the data is around the line of the best fit. Root mean squared error is commonly used in climatographic forecasting, regression analysis to verify experimental results. Now, what is this thing? Let me just uh, hook up my Epic Pen tool. Now you can imagine this thing that this blue line, this particular blue line, is a best fit line, and all these white dots are the prediction lines. Okay, so if you just measure this distance, this distance, this distance, and do the analysis, do the standard deviation, and take up the standard deviation, you will get a number. Okay, and that is the RMSE score. Now, how the RMSE score is helpful, I am not going to explain you this right now, because if I start explaining, you will have some questions that I won't be able to answer, because I would like you to I would like you to understand this in a very practical aspect. That's why when I will be doing this RMSE thing now, I'll be talking about it very more. But you just remember that this RMSE thing is very important for you to understand. It basically it checks the distance between this predicted value and this final best fit line. These are the predicted values. These particular values are the predictive values, and this is the best fit line. And these values what is the distance between these values? The lower the distance, the better the fit, basically. So it calculates that. And but how it is helpful, how it helps in, I have to explain that with a problem. I can explain, but it is better for you to understand with a problem, so that you will have a greater you can have a depth towards it. Okay, so this is all that I am talking about today. I won't be talking much about RMSE right now, because we will be looking at RMSE. We will be looking at RMSE later on this stage, but right now, as we see, we have almost completed everything that we needed right now. So we have I have told you a brief introduction about machine learning algorithms, and from the next session, we will be starting to do some machine learning things. Okay, we will be starting with some machine learning coding, and we will be starting to hard code all the stuff that we have talked about. So if you have any questions, you may ask. Okay, so I think you people don't have any questions. So if you have any questions, just drop that inside in the group, and I'll be answering it as soon as possible. And enjoy the rest of your evening. Goodbye. You can sign off.